Welcome to This Explainer. Okay, let's dive right into something absolutely wild today. We're unpacking a massive paradigm shift, embodied AI. Seriously, what actually happens when our digital minds finally collide with the messy physical world? We're all super used to AI that just talks to us through screens, right? Generating text, whipping up images, drafting our emails, you name it. But what happens when that exact same intelligence steps out of the digital ether and gets a physical body? For decades, computer scientists have been banging their heads against something called Moravec's paradox. Basically, it says that it's incredibly easy to teach an AI to completely destroy a human grandmaster at chess, but it's mind-bogglingly difficult to teach that same AI the basic motor skills to just walk up a flight of stairs. Well, embodied AI is how we finally crack that paradox. Imagine an intelligence that can actually touch, feel, and dynamically manipulate the unpredictable world around it. This is the absolute bleeding edge of tech, and it is fundamentally rewriting how machines learn. And this comparison perfectly captures the shift. Traditional AI, it's basically a brilliant brain trapped in a jar. Sure, it can crunch massive data sets and synthesize human language in the blink of an eye, but it has literally zero physical context. It doesn't know what a gentle breeze feels like or, how heavy a rock actually is. Embodied AI takes a hammer to that jar. It takes that brilliant generative brain and puts it inside an active, moving body. Instead of just scraping the web for text, it's out there using arrays of physical sensors to literally see, hear, and feel the world. This means the system can make split-second decisions and take real physical actions based on what's happening right now, rather than just relying on pre-fed historical data. So the crucial takeaway here is that embodied AI isn't just about complex processing. It's really about learning through direct, unscripted interaction with our reality. Think about a toddler learning to walk. They don't sit down, read a physics textbook on gravity, and then just start sprinting, right? No! They try, they stumble, they fall flat on their face, and their brain subconsciously adjusts their center of mass for the very next attempt. In computer science, we call this physical reinforcement learning, and this new AI operates on that exact same principle. It learns by doing, out here in the real world with real-world physics, slowly refining its understanding of the environment, exactly like humans and animals do. Now, seeing a robot dynamically adapt to its environment feels like straight-up sci-fi today, but the theoretical foundation for this has actually been brewing for decades. Back in the 1990s, cognitive science pioneer Rodney Brooks hit the nail on the head. He argued that true intelligence only emerges from the tight connection between perception, action, and learning. Brooks realized early on that top-down programming, where some coder tries to write an explicit rule for every single possible scenario, it just doesn't work out here. You can't account for every stray pebble or sudden gust of wind. You simply can't program genuine, adaptable intelligence in a sterile vacuum. It absolutely demands a physical, reactive connection to the natural environment. Let's look a bit closer at that triad: perception, action, and learning. This is how true intelligence gets built. First, the AI needs perception, like actually seeing a delicate glass vase sitting too close to the edge of a table. Second, it needs action, the ability to physically reach out and grasp it. And, crucially, it needs learning, because let's be real, the first time it tries, it's probably going to use way too much force and completely shatter that vase. A purely digital AI has no concept of fragility, but an embodied AI logs that specific physical mistake. It learns from the tactile feedback of the shattered glass and the actual sound of the crash. It permanently updates its physical intuition, so it knows exactly how to handle fragile objects the next time around. Mechanically, this whole thing unfolds in 4 tightly integrated stages. First up, senses. High-def cameras, LiDAR, touch sensors, spatial mics. These are the machine's eyes and ears, constantly taking in all this chaotic environmental data. That raw data streams instantly to the brain, where advanced machine learning models process all the noise into a coherent understanding of the space. That understanding then immediately triggers action, firing off complex actuators to perfectly coordinate the movement of an arm or a leg or a wheel. And finally, learning. The system instantly analyzes the result, measures its success or failure, and tweaks its parameters for the very next attempt. And what's really fascinating here is this continuous rhythmic loop: sense, think, act, learn, repeat. This is not some one-and-done calculation, like asking a chatbot to write you a haiku. This is a relentless, millisecond by millisecond feedback loop. The machine acts, the unpredictable real world instantly pushes back. The machine senses that pushback, thinks about it, and dynamically adjusts its very next move in real time. This high-speed loop of micro-adjustments, that is the heartbeat of embodied AI. It is literally the difference between a machine blindly following a script and one that genuinely reacts to the world around it.
When you stack this up against the chatbots and text engines we play around with every day, the contrast is kind of staggering. Traditional AI lives entirely in the digital realm, completely dependent on static text datasets to spit out predictions or code. But embodied AI lives out here with us. Its environment is the physical, real world. Its learning comes straight from sensory experience and actual trial and error. And perhaps the biggest shift of all, the output isn't just a string of text on your monitor anymore. The output is physical action. It's the ability to physically adapt on the fly.
And we are seeing this evolution unfold right now, scaling all the way from everyday gadgets to breathtakingly complex engineering. It starts with stuff you might actually have in your living room, like a Roomba. It physically bumps into your walls, learns the layout, and adapts. Then you scale up to Boston Dynamics' robot dog Spot, which fluidly adjusts its steps to navigate rough, uneven terrain. You've got self-driving cars constantly upgrading their neural nets from millions of real-world miles. And today, the absolute frontier is humanoid robots, like Figure or Tesla Optimus. These things aren't just walking around. They are actively calculating the exact friction of fabric to fold your laundry or navigating highly chaotic warehouse floors to pick up completely unstructured, varied objects on the fly. It's wild. This really highlights why we're seeing such a massive leap forward right now. Adaptable intelligence is just infinitely superior to fixed programming. Think about traditional factory robots. They're essentially blind and dumb, right? They just execute rigid, hard-coded movements on repeat. If you accidentally drop a wrench right in their path, they don't stop, they'll just crash right into it. But embodied AI, it actually perceives the wrench, calculates a new trajectory, smoothly adjusts its path, and just keeps right on working. That adaptability is the ultimate game changer. It's the key to finally bringing robots out of those highly controlled caged factory zones and safely bringing them into dynamic human spaces. And there's another massive benefit here. Physical interaction actually solves one of the biggest, oldest hurdles in computer science. Researchers call it the symbol grounding problem. Look, a large language model can scrape the web and write you a beautiful, technically perfect essay about an apple. But an embodied AI, it actually learns the physical weight of that apple. It feels the texture of the skin. It knows the exact amount of pressure required to pick it up without bruising it. That physical grounding gives the AI incredibly high-quality data that pure digital systems literally cannot access. And that drives a much deeper, vastly richer kind of machine learning. So zoom out for a second, because this isn't just about building a slightly better automated vacuum or warehouse worker. This is about the holy grail of tech, artificial general intelligence, or AGI. A massive consensus of experts right now are arguing that reaching AGI, a system that meets or beats human capabilities across the board, absolutely 100% requires embodiment. Why? Because you simply cannot learn deep intuition, spatial causality, or the basic laws of physics just by reading text in some server farm. True, robust general intelligence requires a body to actively experience, manipulate, and physically test the constraints of our world. In short, we are standing right on the edge of a massive historical threshold. We're fundamentally moving away from AI that merely talks about the world to AI that actively does things in it. We're taking all those breathtaking leaps we've seen in cognitive processing over the last few years, the insane reasoning, the memory, the problem solving, and we are finally handing physical tools to the most powerful digital brains we've ever built. It's the ultimate bridge between software and reality. So, I'm going to leave you with this to ponder today. As intelligence finally escapes the digital jar, what is human society actually going to look like? I mean, how will our homes, our economies, and our daily routines permanently shift when artificial intelligence isn't just a tab you open on your browser, but a physical, capable presence walking right beside you? The line between the digital and the physical is disappearing fast. Thank you so much for joining me for this explainer. Keep questioning the world around you, and I'll catch you next time.